Hello guys, welcome back to VC Tech. Previously we talked about static routing and how we can manually configure them on a router. In today's video we are going to be talking about RIP, the Routing Information Protocol. Even though RIP is considered a legacy routing protocol, it is extremely important for understanding how routing protocols work, how routers exchange routes, and also how networks make forwarding decisions. In this video, I will explain what RIP is and why it exists, and also why learning RIP still matters today, especially if you're learning networking or preparing for certification. So with that being said, what is Routing Information Protocol? Routing Information Protocol is a dynamic routing protocol that uses a distance vector routing. Now, the distance vector here means the distance is how many hubs it's going to take to get to its destination, while the vector is which hub or which direction is it going to take to get to its destination. Now, it has a metric use of hub counts, and it also has a maximum hub count of 15 hubs. If it exceeds 15, it's going to be unreachable, and RIP updates every 30 seconds. Why does RIP exist? RIP exists because it simplifies routing in a small network. It also removes need for manual routes configuration, and it is very easy to understand and configure. When we get to that phase, I will show you how easy it is to configure RIP on a router. It is considered one of the first routing protocol ever developed. And lastly, the importance of RIP. RIP teaches us the core routing concepts. It also helps us to understand the distance vector behavior, the routing loops, and the counts to infinity problem. As I said, RIP has a maximum of 15 hub counts. If it exceeds 15, then it is going to be unreachable. Now the importance of why RIP is actually important, because it builds the foundation for how to configure OSPF, EIGRP, and BGP. These are configurations of routing protocol that we are going to see in the coming video. So with that being said, guys, let's head over to our lab so we can see how to configure this on a router. So for this tutorial, guys, we are going to be using 3 routers as we have here, and 2 switches with 6 species IP. If you look closely, you're going to see the network IP for this local area network, and this IP address for this connection here. This is a wide area network connection, same as this one with this IP address, and this IP address for this local area network. So for this tutorial, we have 4 different IP address. First, let's assign IP address to the interfaces on the router before we get into the main activity for today. So for this interface, we are just going to do it via this way so we don't waste much time. Now the interface on the local area network will be taking 128.64.1.1 for the default gateway, and we've assigned IP address to this interface on the local area network. Now let's assign IP address to the rest of the interfaces on the router. We still go to interface gig 0/1 and we say 10.10.10, and we want to give this interface .1, and we also want to make this a /24 network. We've assigned IP address to this router. Let's do the same for this one. So interface gig 0/0 or gig 0/1, sorry. be taking 10.10.10.2, and the subnet mask is going to be 255.255.0. We also need to power it on. And as you can see, guys, we are able to gain connection for this interface. Let's do the same for this interface and this local area network. So interface gig 0/0 will be taking 10.10.10.20.2 to 10.10.10.20.2, since the other interface took .1, so this will take .2 with yes with the 2.24 network. Now we've assigned IP address to this router. Let's do the same for this router over here. We'll be starting with interface gig 0/1. So this will be taking 10.10.20.1 255.255.0. So now let's assign IP address to the last interface for this tutorial, which is gig 0/0. This will be taking 192.168.1.1 or 10.10.1 for the default gateway. And guys, we are able to assign IP address to all the interfaces on the router. Now let's try something. Let's try to ping from one device in a local area network to another device in the other local area network, and see if we are able to gain connection. So 64.1.5, let's give this .5. Default gateway of .1. Let's try to ping the default gateway and see if it's possible. 128.64.1.1. Yes, we are able to ping the default gateway of that local area network. Let's also check for this. Let's assign IP address to this device and also try to ping the local area network and the other network 192.168.10.1 as the default gateway. But let's try to ping the default gateway of this local area network Let's try to ping. So 192.168.1.10.1. We are also able to ping the default gateway of that local area network. However, let's try to ping across to the other network. Remember, guys, we've not configured routing protocol, so I doubt if this is going to work, but for the sake of knowledge, let's try to ping the default gateway of this local area network. As you can see, guys, we are getting destination host unreachable because we've not configured a routing protocol on the router. So that is going to be our next phase. Let's head over to the routers and configure RIP on the router so we can be able to ping one device that is in a different location. So guys, how do we configure RIP on a router? We just say router RIP. Now we are in the routing protocol interface. We also want to specify that we want to be using the latest version, which is version 2 of RIP. Then we want to specify no auto summary. And remember, guys, we advertise all the networks that are directly connected to the router when we want to configure RIP. Now for this router, how many networks are directly connected to it? If you said 2, then you're correct. This network and also this network, they are directly connected to this router. So we are going to say network. We want to specify the network that are directly connected, 128.64.1.0. We also want to specify the 10 network, 10.10.10.0 network. By doing this, guys, we've configured RIP on this router. Now our traffic can be able to go from this device up until this interface over here. We've configured RIP on this router. Let's also head over to the second router and do the same configuration and also advertise the networks that are directly connected to it. So what do? We say router RIP, and we say we want to be using the latest version, which is version 2. We also say no auto summary. Then we advertise the networks that are directly connected to that router, which is 10.10.10.0 and also 10.10.20.0. We've also configured routing protocol, RIP routing protocol on this router. Let's head over to the last router and configure a routing protocol and try to ping with the device we previously used and see if we are able to gain connection. So for this, just the router RIP with the version 2, no auto summary. Then we want to advertise the network, which is 192.168.10.0 and also network of 10.10.20.0. So by doing this, guys, we've configured RIP routing protocol on all the routers. Now let's try to ping once again and see if we are going to gain connectivity. So we want to be pinging 192.168.10.1. As you can see, guys, we are able to ping the default gateway of this local area network, the default gateway of this local area network. As previously, when we tried to ping the default gateway of this local area network, we were getting destination host unreachable. Now let's try that one more time and see if we get the same result. Fortunately for us, our configuration was accurate, and we've configured RIP routing protocol on all the routers, so that is why we can gain communication from one local area network to another local area network. And we can also trace routes to see the routes that the packets or the data that we are sending is taking to get to its destination. So we can do that by saying trace route and the IP address of the destination that you want to go to, which is 128.64.1.0. So as you can see, it left the default gateway of that local area network, which is 10.1, and it went through the next hub. If you notice, I have something here called hub count. I would explain that shortly. And it went through 10.10.20.2, which is on this interface right here. Interface gig 0/0 has the IP address of 10.10.20.2. So it went to the next hub, which is this interface, before it got to the default gateway of the local area network where we are trying to go to, which is this interface. RIP routing protocol uses 15 hop counts as the maximum. If it exceeds 15, then it's not going to work, because the maximum is 15. Now, the hop count is from this router to this router is just one hop. There are 3 routers, however, this is the next hub destination, which is the vector. So remember, it has a distance vector behavior. Get this out. So distance vector, the vector is the direction it takes to get to where it's going to, which is this interface over here. From this router, the next hub is the interface of this local area network that is connected to our local area network. So interface gig 0/1 is the next hub from this router over here. Now we have just 2 hub counts for this tutorial, because from this router to here, which is the next hub, is 1, and now from here to this interface is 2. So we have just 2 hub counts for this tutorial. Now the distance is how far it takes to get to its destination, and remember, we have only 15 as the maximum. Now the hop count here, it counts how many router that the packet is going to go through before it gets to its destination, and remember, it is supposed to be only 15. If this video helped you understand how to configure RIP routing protocol on a router, why not give me a like and subscribe to this channel, because we are going to be talking about more interesting and fun routing protocols, ERP, OSPF, and BGP. So stay tuned, click the like button and subscribe to this channel so you don't get left behind. Thank you, and see you in the next video.